This process that we've described for a sender sending packets one at a time, making sure it gets acknowledgement back from the receiver and retrying it, it's being very careful and simple in that way, but then it turns out it's also slow. Because the problem is, if we have a lot of data to send, we are waiting after each piece of data to get that acknowledged before we send any more. And that means that our overall throughput, because we're waiting for the second piece of data for everything to be done with the first piece of data, our throughput is going to be limited by latency. That is how long it takes to do this full round trip. So what we would like to do instead is have the sender send a bunch of data all at once. And that data can go through as separate packets to a large degree parallel, and that they're hitting different routers at different times and eventually getting to the receiver, kind of streaming through a bunch of data. And at some point, making sure that it's all acknowledged from the receiver, but it doesn't have to be necessarily in order or all at once. And once we get enough acknowledgements, we might start going with some more packets and so on. So what this means is that our sender and receiver need a way to track multiple packets in flight. So from the sending host perspective, there are a sequence of packets that correspond to the data that the application wants to send. The application may send even more data later, but we're just looking at the ones that the transport layer knows about so far. Even so, it has packets that it has sent and that it's received acknowledgments. It has some packets that it's sent, but not yet heard back from the receiving host. And then it probably has some packets that it hasn't even had a chance to send yet. It doesn't want to send them all at once because it doesn't want to overload the network, say. The receiving side similarly has some packets that it's received and acknowledged. So these packets are, in a real sense, done. Maybe they still need to be delivered to the application layer, but they're done as far as the transport layer is concerned in its communication. And then there's going to be some packets that it hasn't received yet or that it hasn't acknowledged yet. There's a word for this boundary between the dark beige and light beige, between the ACT and not yet ACT packets. On the sending side, that's called the send base, and on the receiving side, it's the receive base. So the send base basically is the point in the stream of packets on the sending host where it still needs to do something. It's not yet done. And the receiving base, similarly, is a place where we still are working on packets and letting the other side know that they're done or we're waiting for them. When this receiving host gets a new packet in, then it's not immediately acknowledged. Could be for various reasons, but at least it still has to decide to send an acknowledgement at some point. So there is at least some time that it'll be the light beige here on the receiving side, and then the receiver sends an acknowledgement back, and as far as it's concerned, that packet is fully delivered. On the sending host side, it's going to wait until it gets that acknowledgement, and then when it does, it can increment its send base. It also thinks that packet is all done, and probably as it increments its send base, it can send one of these packets that is not yet sent also. That is, it might retain a basically fixed size window here. The window is a choice about how many packets we think it's worthwhile having live in the network at a time, so as to improve throughput but not overload the network. So this window size, like the timeout, is something that an implementation will need to get right and to carefully consider.